Hello, everyone. Dr. Anna here for Couch Talk. And today we have an incredible guest, one of the women on the frontier of functional medicine, a true go-getter and just incredibly knowledgeable in the field of functional medicine, natural medicine. I want to introduce you to Dr. Kara Fitzgerald. Kara, it's great to have you here with us today.
Oh, it's great to be with you again, Anna.
I know, I'm excited. Y'all, we're going to be talking about methylation and some key factors of methylation. By now, you've heard the buzz around methylation. Do you have, do you have MTHFR gene and then these factors that come in? So we're going to dig into that and kind of clear up some misconceptions and talk about really what we need to know and how it affects us. And I'm excited to talk about this today because it's such an important area in medicine.
Yeah.
So I'm going to introduce Dr. Kara Fitzgerald to tell you a little bit about her. She received her Doctor of Naturopathic Medicine degree from the National University of Natural Medicine in Portland, Oregon, and she completed the first Council on Naturopathic Medicine accredited postdoctorate position in nutritional biochemistry and laboratory science at Metametrics Clinical Laboratory, which is now Genova Diagnostics, under the direction of brilliant, kind Dr. Richard Lord, who I've known well, and just brilliant.
Yeah.
These two, just brilliant, let me tell you. Her residency was completed at Progressive Medical Center in Atlanta, Georgia. And now she is up in Connecticut, where she has a clinical practice, also involved in research. And she's also the lead author and editor of Case Studies in Integrative and Functional Medicine. She's a contributing author to Laboratory Evaluations and for Integrative and Functional Medicine, and the Institute of Functional Medicine's textbook for functional medicine. She recently authored the ebook called The Methylation Diet and Lifestyle and published numerous peer-reviewed articles in multiple journals, is faculty at IFM, is just brilliant all the way around, and does this awesome podcast as well. I was telling her earlier before we started the call, one of my best and favorite interviews has been with Dr. Kara Fitzgerald. So you can find her website at drkarafitzgerald.com. So DRKARA Fitzgerald, FITZGERALD.com. We'll give you those links in the show notes and all that. But welcome, Kara. So excited to have you.
Thanks, Anna. It's great to be. Yeah, I know. It's great to be back with you. We had a great podcast. We were just kind of walking down memory lane. Yes, people, be sure to check it out. I just plied Anna for all the pearls that I possibly could, that I wanted to know as a physician and as a woman. So anyway, we'll move from your podcast and talk about methylation.
Yeah. So if y'all didn't hear it, definitely go to Kara's site and listen to that one too. And it's one that, really we have to listen to again and again. I mean, there's just so much in there. Take good notes. But you do the show notes, which is great too. All right, let's dig into methylation, Kara. Let's just go in and talk about methylation. What is it? Why is it so important? Why do we need to know if we're a good methylator or a bad methylator?
I know, right? It's a big deal. It's a big deal. I was laughing today. I was on a meeting with somebody else, and she was actually finding some of the content we have on our site on methylation as being really helpful for the layperson because she otherwise doesn't understand it. And I encounter it's hard to understand. I encounter that all the time. What the heck is methylation? Unless you've been doing the drill down for a long time, it's like it's a foreign language. So let me and you know what? It's so ubiquitous, it's happening all of the time that even I think sometimes it's so obvious that it actually increases the complexity. But let me back up and talk about what it is. So a methyl donor, I always have a methyl donor kicking around here, but I think I have a molecule kit. I build molecules, and I was actually building them with my nephew, and I think I gave him my methyl group. It's literally just a carbon and 3 hydrogens, and it's like one of the smallest biologically active molecule. It's itty bitty, 1 carbon and 3 hydrogens. And so methylation in the body is the process of either making that compound in the methylation cycle or actually using that compound. And we use that compound, Anna, like everywhere in every cell. cell all of the time. It's this background activity that is so fundamental and so important. It's happening in every cell all of the time. And so if it's gunked up, if there's an imbalance, if you're not making enough of these methyl donors, we actually make a compound called, it's a big word, called S-adenosyl methionine in the methylation cycle, and that, shortened to SAM or SAMe, that is the compound that actually has that methyl group on it that goes around, into all the cells and involved in all sorts of metabolic processes, and it gives that methyl donor. And then sometimes methyl donors are also taken from compounds. So it's involved in activating immune cells. It's involved in DNA synthesis. It's involved in regulating DNA expression. It's involved in making and metabolizing neurotransmitters and detoxing estrogen, in making, helping form cell membranes and producing compounds like choline and acetylcholine. Actually, that's another neurotransmitter, but just on and on, all over the place, all of the time. Major fundamental activities in the body require healthy, robust methylation.
Mm-hmm. And that just brings to mind too why one size fits all medication doesn't work, or one mechanism of action medications don't work or have a flaw in the system, because nature has created every piece to have multiple roles. And these, like methylation, it's a building block, right? It's foundational, like you said. And so if we look at this foundational and an important part of, especially like our mental health, our neurotransmitters, our ability to fight cancer, our ability to have hormone stability throughout our life, right?
Yep. So one of the reasons I think it's difficult for people to grasp, to kind of wrap their head around, you can't say, and it's not easy to say, oh, I have a methylation problem, or now sometimes, we see in clinical practice, and I think, the regular folks have gotten sometimes depression, seems to be associated with it. What else? Autism. When we're treating autism, it tends to have, major methylation issues. But it goes out from there. Really, most conditions, from autoimmunity to inflammation to accelerated aging to dementia to, as you pointed out, cancer to heart disease, metabolic syndrome, or being on the metabolic disease, all can have associated with them some degree of methylation imbalance. And and there's a continuum, so it's not all or nothing. It's not always a methylation issue, but methylation imbalance can absolutely play a piece of the or be a significant piece of the puzzle in a lot of conditions.
Yeah, absolutely. So let's talk about, how do you know if you have a methylation issue? Genetic testing, the biomarkers.
Yeah. So an area that I want to jump over to is epigenetics, and we'll talk a little bit about what I'm doing there and what the research study that we're working on now. How do we identify whether or not we have a methylation issue? Well, you've probably heard of the compound called homocysteine. When we see homocysteine elevated, we think it's a cardiovascular risk marker. I mean, that's really what it got put on the map for. It's also a universal, when elevated or when too low, it's unequivocal evidence that methylation is in imbalance. And our major methyl donors, the nutrients that we need in our diet to help get this cycle, to help optimize methylation, include B12 and folate, the compound betaine, we need niacin, we need riboflavin, we need a complement of minerals, including magnesium and potassium, zinc, fish oil, etc. All of these compounds can help regulate methylation. So one marker that your doctor will look at is homocysteine. We can also look at folate levels and B12 levels. We can look at, a lot of clinicians are interested in looking at genetic mutations. In fact, you may be familiar with some of the methylation single nucleotide polymorphisms, such as MTHFR, and there's a host of others in the methylation cycle. And when those are variant, or when those are subfunctional, they can, but not always, they can contribute to methylation imbalances.
Yeah, no, that's good. And that's one thing that I started checking several years ago.
Yeah, especially in your world, absolutely.
Yeah, homocysteine levels, and
Hmm.
how key that was, and then looking at understanding, MTHFR, and how
Yeah.
that can be one of the risk factors for certain diseases and disease processes, also for why a person's not getting better with first line therapy recommendations. So that's helped in a lot of ways, and just kind of teasing that out. So what do you like your homocysteine level to be?
I think a perfect. There's actually, if you're a clinician out there, there are other compounds we can look at to shine a even brighter light. We can look at SAMe. We can look at the metabolite of SAMe. Once that methyl donor is used, it becomes S-adenosine homocysteine, and then it becomes homocysteine. So there's a whole we can dance around the methylation cycle actually pretty nicely with different biochemical markers. But homocysteine is the tried and true, and we can get it super easy. We can get it at Quest or LabCorp, and it's insurance covered and so forth. I like a homocysteine in the neighborhood of 7, maybe 6 or 7. I don't want it high, and I don't want it too low. So I want to see it balanced. How about you?
Yeah, exactly. 6 to 8,
Yeah,
not too high, not too low. And,
yeah.
and it brings different, let's just talk, it brings different reasons, right? What do you do when the homocysteine's too low?
Hmm. Well, it can be low for different reasons. So most commonly, homocysteine, we think of it as a bad guy, and it's associated with heart disease when it's too high. So it has a bad reputation, but in fact, it's essential for the production of glutathione, the taurine, and some other, really for sulfation, I should say. So for detoxing the body. So homocysteine is a really, really important player for a host of compounds. That help us, help maintain our adequate antioxidant supply, help detox the body, and so forth. So we really need homocysteine. In times of increased oxidative stress, increased inflammation, methylation, so homocysteine is normally recycled to the amino acid methionine, and then methionine is metabolized to make that methyl donor, S-adenosine methionine, and then it's reconverted back into homocysteine. So that's the methylation cycle in a super nutshell. But in times of oxidative stress, the enzymes that allow for homocysteine to recycle actually grind to a bit of a halt. They're blunted, and then homocysteine is available to get shunted into what they call transsulfuration pathway, and ultimately to make our major endogenous antioxidant, the major antioxidant our body needs under times of oxidative stress, and that is glutathione. So without sufficient homocysteine, one of the first things we think of is that it's being spent in quenching oxidative stress. So low homocysteine might mean that we're under a lot of oxidative stress and we need glutathione. That's really actually the most common reason. Sometimes we'll see a low homocysteine because there are lesions with the various enzymes. So either there's an issue and there's just insufficient nutrients to adequately recycle, or there's genetic damage to those enzymes, and for whatever reason homocysteine isn't being produced adequately, or S-adenosine methionine isn't being produced and then converted down to homocysteine. So there can be other sort of a little bit more obscure reasons why one might see a low homocysteine, but far and wide it's oxidative stress on the body, and the homocysteine is doing its job. And then we need to just replenish it. Well, we want to go in and quench the oxidative stress, figure out what's going on, take care of the body, and then make sure that we see those numbers restored, that we have adequate supply in the body.
Yeah, no, I think that's a great explanation. But you're right, by and far, we see the elevated homocysteine.
Far and away, yep.
Yeah.
And then we're thinking about what kind of nutrients we need to actually support recycling that homocysteine so that it's lowered, and we're again able to produce that all-important methyl donor compound, S-adenosine methionine. So if homocysteine's too high or too low, ultimately what's going to be at issue is we're not going to have enough S-adenosine methionine, and methylation happening all over our body is going to be compromised to one extent or another. So again, we're not going to be able to make or regulate DNA expression, or metabolize out our our histamine or estrogens, detox the body, et cetera, et cetera. So imbalanced homocysteine, be it high, which it more commonly is, or be it low, we're messing with this global methylation that we need to be robust and functional.
Yeah, no, absolutely. That's good. Thank you. Well, tell us, what are some of the clinical issues that you're typically seeing with elevated methylation then?
Yeah, methylation imbalance, hyper.
Yeah, so elevated homocysteine are right. And
okay.
imbalance, I know, inefficient methylation. And what percentage of us now, because we used to always quote in obstetrics, well, 10% of us have a methylation defect, but I think that's quite low, right? It's a lot higher than that, isn't it?
Well, interestingly, Anna, if we look, single nucleotide polymorphisms in the methylation cycle are so ubiquitous that all of us have at least a handful of them. We all do. And it's just really a matter of whether or not our lifestyle allows us to really support healthy methylation or not. So again, thinking about issues associated with methylation defects, accelerated aging, autism, birth defects, miscarriages, dementia, autoimmunity, heart disease, depression, Down syndrome actually has methylation imbalance, hyper and hypo, thyroid disease we can see. Really kind of the gamut, we can see evidence of methylation imbalances. So it's worth it. I would say that it's a foundational area of exploration for any clinician practicing functional medicine. We're all looking at how methylation is.
Yeah, and I like what you said. It's like, it really depends on that lifestyle. So
I'm going to talk about that.
Yeah. Let's talk about that. But first, just how did you get interested in treating methylation?
Okay, good question. And then we'll circle back to lifestyle. So all of us, again, in functional medicine, with my background in laboratory science, I've been looking at homocysteine, I've been looking at other biomarkers associated with methylation. And then, as we mapped out the genome and single nucleotide polymorphisms became something that we could look at readily. Of course, I was looking at those as well, along with you and most of people who are practicing functional medicine. So a lot of my patients needed methyl donors to one extent or another. I wanted to give them B vitamins, betaine, et cetera, choline, and so forth. But then one of the things that really interested me powerfully is I started to read about the epigenome. Epigenetics it's been around for a little while. It's certainly newer than genetics, but the term has been around, since the early 19th century, or 20th century, 1900s. But really understanding the epigenome and actually being able to measure it in a laboratory to identify what's happening is new. So epi is above, and then genome, epigenome, above the genes. And so we know now that there are actually processes or mechanisms mechanisms actually regulating how DNA is expressed, and that whole field is called epigenetics. So DNA, or any genetic material, produces proteins, kind of dictates how the body behaves. And we think about our genetic mutations as sort of deal breakers or not, when in fact what we now know is just above that is this epigenome. And actually the epigenome regulates how the DNA expresses. And the epigenome, that layer above the DNA, is kind of where the rubber meets the environmental road. So whether we're eating well, if we're getting enough sleep, are we exercising, how's our gut health, etc., that all of these variables, all of these environmental variables actually influence the health of the epigenome, and then the epigenome in turn regulates how our DNA expresses, regulates whether or not that MTHFR mutation is really going to make a big difference in our world or not, the epigenome. And so I started to read the literature around it, and I became extremely fascinated. It turns out that a lot of the complex chronic diseases we see in practice are sourced to imbalances in the epigenome. And what was really interesting to me, Anna, was that regions in the epigenome can be hypermethylated, tons of methylation going on, and other regions can have hypomethylation in the same gene. And regions of hypermethylation, so generally suppress that gene activity. Well, it turns out in cancer, most of, I mean, in every type of cancer that I've read about, to my knowledge, always have these regions of hypermethylation that shut down the gene that inhibits cancer. So those tumor suppressor genes that are incredibly important, say P53, for example, or even the BRCA, a functioning BRCA protein, in certain cancers, they can be hypermethylated and shut off. Conversely, oncogenes, which can actually promote the spread of cancer, are hypomethylated and turned on. So methylation on the epigenome will shut off genetic expression. Sometimes that's an extremely bad idea. Sometimes we want to shut off genetic expression, but sometimes we don't. And likewise, sometimes we, when something's hypomethylated, well, we might actually want it hypermethylated. So, long story long, it turns out that this dance of methylation is so much more than just on-off, to have enough or not to have enough. It's a homeodynamic process that's happening that entails us to really embrace this whole being medicine. Every aspect of functional medicine really seems to influence whether we're methylating in a balanced, healthy way. And it goes way, way beyond the idea of just making sure you have enough B12 or folate or, choline or whatever nutrients that you're using for methylation. It goes way beyond that. Turns out a lot of these foods that we use, God, I bet if we looked at maca, we would find maca has favorable epigenetic balancing properties. I bet you, Anna. It may not be researched yet, but when it is, it would be super cool to see that. But it turns out some of our go-to botanicals, some of our go-to nutrients have this balancing capability on the epigenome. It's so interesting. So, for instance, EGCG, that powerful flavonoid in green tea, turns out that is what we call an epigenetic adaptogen. It's balancing. That's probably why it's so potently anti-cancer, why it's so potently protective. We're getting to it blows my mind. It's so cool. Curcumin, it's an epigenetic balancer. It's a methylation adaptogen, as we like to call it. A lot of those, our beloved polyphenols, have this adaptogenic property. It's like Goldilocks, too little or too much. Well, let's get in there and make it just right. So these foods that nourish us so powerfully turn out to have this really cool interface on the epigenome. Now, let me also say, though, we have to have enough of the methyl donors also. So we want these balancing guys in the mix, taking care of us, allowing us to have the most optimal expression as possible. But we also need to make sure we've got enough of the methyl donors, the B vitamins, the folates, the cholines, and so forth, so that we've got the ingredients to let the body manage the epigenome. So my work has been, how can we get this from a really food-forward approach? One, so that's why we've got the methylation diet and lifestyle. How can we have a diet that's densely packed with methylation balancers or methylation adaptogens, as we call them, plus, just rich in methyl donors? So that's one thing that we've been working on. And the other super cool thing, and then I'll stop and let you ask me some questions. It turns out that all of these lifestyle factors absolutely influence methylation in the epigenome, big time. If you got enough, did you get enough sleep last night? I mean, if yes, maybe. I remember when I was actually talking about this last year in Ireland, and I was totally jet lagged. Well, it turns out just one poor sleep night, one sleepless night. This is in an animal study. It's not humans. Some of the data are really new. Influences epigenetics profoundly, and in a negative way. And even when you catch up on your sleep in the short term, epigenetic expression or DNA expression is still negatively impacted. Just one sleepless night. However, conversely, when you have a nice, robust, good sleep habit, you're nurturing your epigenetic expression. You're nurturing optimal DNA expression. It's pretty cool. Same thing with exercise. Same thing with good gut health. All of these bugs living in our gut make compounds that aren't necessarily the methyl donors as we understand them. Sometimes they are. I mean, we can make folate. Some of our bugs make folate in the gut, but they're all these regulators, these things that attenuate and balance and tweak and fine tune. So a good, healthy gut has it's so much more going on than we knew. And so for me, I started as a clinician to wonder, well, if I'm giving Joe, 10,000 micrograms of B12 and 5 milligrams of methylfolate long term, I started to wonder, am I potentially setting them up for some of these conditions of hypermethylation? Is it possible that I would promote cancer? I mean, it was logical for me to read this and wonder how I, as a clinician, might be doing something not appropriate for my patients.
Yeah, or it's like that creating that negative feedback loop that we're not producing our own now because we're supplementing. So I
that's
get
true.
Are going down this trail, like, okay, when there's a sweet spot. And
yes, there's a sweet spot. I know, it's amazing. And so we know when you have an elevated homocysteine, no question about it, you probably need some B vitamin. I mean, there is a place for our supplements. There's absolutely a place for in our toolkit for methylated folate, et cetera, no doubt about it. But what we do have to recognize that we don't want to just throw our patients on some of these nutrients long term and forget about it. Or if you're out there, if you're a consumer and you're going to the health food store and buying yourself a bunch of B12 because you think it's the right thing to do, well, be mindful about it. I mean, we know now that these guys are very powerful players, and this new research into the epigenome is kind of where the rubber meets the road. However, you can do a food-forward approach. There is no data, to my knowledge, that food-based folate has ever caused cancer. Not the fortified and fortified processed grains and so forth, but your leafy greens, that's not a cancer-causing concern there. But go ahead. I'm going to hush because I know.
No, I love this because it just gets me excited because, when we're talking about what's happening with the genome, right? That there's hyper and hypo function of the sites on the membranes and what is happening. So there's this balance, this body ability to auto-regulate itself, right?
Yep.
So it's like same thing. You can't flood too much, and that makes sense. It's really exciting how intelligent the body is and how nature
so intelligent
to work its way through that. And I will say, in like my idea of supplementing, that there's seasons for a reason, right? We have to rotate. There's maybe winter off or winter on.
Yeah.
I mean, like, when do we take drug holidays, vitamin holidays, things like that, and changing up our dietary pattern too. So those are factors. So how did you come to terms with that? But I do want to say this because I think it's so key, is that, like, diet alone, like I was saying, for weight loss, diet and exercise alone are just part of the picture, right? As you mentioned, lifestyle, sleep, that's a huge rejuvenator. That's a huge part of our healing process. And so it's more, there's so many more, there's so many other aspects that we have to integrate into our lifestyle that go beyond the eat better, move more. That's part of it for sure. Yes. There's a lot more, especially when we look at the disruptors that you talk about. And you mentioned also in your ebook, the toxins and the environmental disruptors and all this. Yeah. Let's go into the lifestyle and just talk more about.
It's true. So when we started to put this together, and design our whole program, we were thinking as holistically as possible. So you're right. So you want a good diet, you want enough sleep, you want to get balanced exercise, you know, you don't need to go too crazy. I mean, there's actually a point where exercise is harmful. So if you decide that you need to go bang out your CrossFit, 7 days a week, that might not be the healthiest for optimal genetic expression and disease prevention. Now, granted, one person's fitness is another person's totally overdoing it, right? So you need to just be in there with what makes sense to you. In the research study we're doing, it's just we're recommending people go to around 60% of their max and do that, at least 5 days a week. But know that overdoing it, if your body isn't up for that, is damaging. Actually, there's plenty of research, and it's damaging to the epigenome and elsewhere. So exercise, but yeah, as you were saying, Anna, toxins, just limit our toxin exposures. Toxins will disrupt epigenetic methylation expression, but they'll also drain those precious methyl donors. So that SAMe molecule I was talking about that has the methyl group on it, well, in order to metabolize a number of toxins, it's in demand. So you'll use it up to get rid of those toxins rather than, say, metabolize out that estrogen that you need to get rid of, or metabolize out that adrenaline you need to get rid of, or take care of the methylation on the epigenome, etc. So yes, a toxic burden in the body, excess toxic exposures, is going to damage methylation and be a methyl donor drain. We also know that there's loads of medications, that can drain methylation, and it's important to look at, patients to see what's going on if they're draining methyl groups with the medication they might be taking. If it's allergy season, as it is now here for us in Connecticut, histamine uses a boatload of SAMe, of methylation, to get it out of the body. So allergies are a methyl donor drain. Stress, again, just pumping out the adrenaline, just being really wound up and anxious, another methyl donor drain. And an imbalanced microbiome is going to, for many reasons, not the least of which, we can make folate and do all sorts of stuff, is going to impact negatively methylation. So you can cast a really wide net for ways that we can tend to methylation in our body.
Yeah, no, I love that. That's true. So what are some of your recommendations? Well, what are some of the food choices that you recommend?
Yeah, I just think this whole idea of the methylation adaptogen thing, I just think it is so cool. It's so cool. I just love that we've got these foods that will help. If you're hypo, you're a little hypo, you're a little hyper, well, it looks like some of these foods are going to actually help us balance it out. So for that reason, my love affair with curcumin continues, because the research on curcumin, as far as balancing methylation, just comes out all the time, like every single day. When I wrote our ebook, I wanted to see how many hits there were on PubMed, our research database. And at that time, there were 85,000 on epigenetics. I'm sure if I went back and did it now, there'd be like 150 or 200,000. Research is coming out every day, all of the time. And curcumin is one of the big ones that people are looking at. Of course, I like green tea. I think green tea is amazing. And rosmarinic acid and rosemary. I mean, we know rosemary is really great for memory, and it's an antioxidant. It's got all sorts of active polyphenols. Well, rosmarinic acid is what we call a DNA methylation adaptogen. Eggs, I love eggs for choline. So we also want in our diet, we want methyl donors, not just the adaptogens, but the donors too. So we want things that will help us recycle homocysteine, like we talked about at the beginning. So you want some animal sources, you want some forms of B12 in your diet, ideally. If you're a vegetarian or a vegan, then obviously you need to be supplementing with it. And then greens, lots of greens. And then we want, rich a diet high in good fats and, nuts and seeds. We have a whole bunch of methylation superfoods that we go into in the book. Pumpkin seeds are fabulous. Shiitake mushrooms is another really great methylation adaptogen. It's like all of these foods that you're telling your patients to eat every day, the research is coming down the pike saying that this is really one of the major mechanisms, this methylation adaptogenic property. So it's really cool. Tomatoes, lutein, lycopene, again, methylation adaptogen properties. Super cool stuff. And likely, I would say to your audience, I'm sure you guys probably had some methylation adaptogens today, and you probably had some foods that are rich in methyl donors. I think the idea for us, though, is that we want to turn the volume up sufficiently, and not just diet, but lifestyle too.
Yeah, I agree. Those lifestyle factors are key. So with that, let's tell us, what is your favorite food that you love to eat that just makes you feel good?
You know what? I forgot to say beets. Beets are definitely a methylation superfood. I would be remiss. I did this book. My co-author is my nutrition director, Romilly Hodges, who I just love. And, she did such a good job on pulling together our diet for us. So the food that I love, that I eat a lot, actually, it's a spice. Rosemary has been on my major hit parade and makes it into virtually everything that I eat almost every day. And I grind it up fresh if possible. And I just love it. So it's a methylation superfood, and I just have a very strong taste for it.
I love it too. And do you grow it yourself? Do you have it growing?
I'm not that, are you good at growing it? I have to be honest with you. My mom has about 20 rosemary plants, and I get them from her. She's more successful. Are you a successful rosemary grower?
In the backyard. Yeah, I have a huge bush.
Oh, that is so cool. You'll have to put a photo up with this podcast. I want to see it. So in Connecticut, our bushes are a lot smaller, and they're finicky. So I get it from Mom. Thanks, Mom, if you're listening.
Yeah, awesome. Taking care of you.
I take curcumin in capsules. I don't feel like, now I recommend obviously loads of curry.
Yeah.
Coconut milk is good, doing a coconut curry. The medium chain triglycerides, of course, are fabulous also for methylation. But I just want to ensure that I'm getting some curcumin every day. So I also use it encapsulated. And I eat a lot of greens. I love arugula. I love Swiss chard. So I just, every day I have, I don't know, probably, 6 to 10 cups of greens.
That's awesome. Yeah, that's key. Now, with your, I was going to ask you about, now I had totally lost it because I was thinking about beets, and those are really, you mentioned, are alkalinizers. Oh yeah.
Yes, that's right.
Mighty Maca contains curcumin and EGCG. So really, green tea extract. So we're really, was part of it, and resveratrol, which is probably...
Oh yeah, resveratrol is also a methylation adaptogen, another really good one. And so, yeah, it's a great product.
Yeah.
It's just for those 3 mechanisms, and I'm sure eventually we'll see research on maca if it's not already out there.
Yeah, no, I haven't seen it, but that's interesting. I expect it will be too. It just has that kind of covering effect, too high, too low. We've known that for the adrenals, but it'd be interesting.
Yep.
On the
That's right.
level. All right. So what is the number one lifestyle hack that you are implementing this year?
My number one lifestyle hack, I would say that so I have a bike I have pedals under my desk.
Cool.
I do. Yeah. So I can be in meetings, I can be in a patient encounter where we're doing the desk a lot, and I can keep my legs moving. And I do it all the time. And I should say I try to do it as much as possible, because I sit way more than I like, and I need constant antidote to the impact of sitting. So I've got steps, and I stand, and I work at my desk standing. I know those aren't quite as sexy as they could be, but I mean, we need to be moving. I need to be moving. I do exercise. Actually, let me say that. I do exercise. I love exercise. I love being outside exercising, but that's insufficient when I then spend a good chunk of time at my desk.
Exactly. We are not
those are my
this immobility and this type of lifestyle. All right, then one last question. What do you do for fun?
What do I do for fun? You want to know something? I haven't said this in an interview. I mean, I love riding my bike. I've said this a zillion times. I used to compete as a cyclist when I was in med school, and I loved it. And I still get so much out of it. But I have taken up knitting.
Awesome. Oh my gosh, that is awesome.
Isn't that? I have made I'd say most of my family now have scarves. I'm an expert. Well, I don't know that I would say expert. I'm a very slow scarf knitter, but I kind of like the hand movement and the bilateral stimulation. I don't know. I think it's like a spinner, one of those spinners kids have.
Yeah.
I think it's like a spinner that you can actually end up with a scarf in the end if you're like me. I mean, I couldn't make a hat, or I couldn't do anything better than that, but yeah, I
That's so
knit.
awesome. But there's so much therapy to this hand movement.
It is. Yeah, I think so.
Both hands and challenging your brain, and that's so good. Well, I'm going to take a knitting class. I am decided.
Are you?
Yeah, I
Oh,
am.
good for you.
Your motivation. So I'm going to do that and just try to get. I used to crochet and needlepoint. I said that made me a good surgeon. Needlepoint.
Oh my gosh, yeah.
But,
absolutely.
yeah, I feel like okay, I need to use both hands together, and that would be fun. That's so awesome.
Yeah.
So tell people now how to get to your program, and we'll definitely put links below, but to do your methylation program and also your ebook.
Yeah. Okay. So go to drkarafitzgerald.com and you can, you'll see that there is a whole page dedicated to all things methylation for us. We are going to put links on the website, so we'll give you a discount. You can get the ebook. We also have a really cool methylation balancing program. So the ebook is written a little bit dense, a little bit more towards professionals. And incidentally, we will be doing a professional training, a day-long intensive in methylation. I am going to South Africa next month and launching the training, and then we'll bring it back to the US. So if you're a clinician listening, or if you're a super savvy, regular person and you want to jump in, we are going to be launching that. We'll offer it here in the US in January. So you can get the book, or you can just do the methylation balancing program. We've got a big, robust nutrition team of brilliant people who are well-versed in this. Most of our patients, actually all of our patients, will incorporate the methylation diet and lifestyle into the program, into whatever foundational programs they have. So if we've got somebody with SIBO, they'll be on a low FODMAP diet, and then we'll layer in the methylation superfoods as we can. So we layer it into everything that we do, but somebody could come in and just dive into the full program, do the methylation balancing program. It is just a great foundational wellness protocol.
That's so good. Are you doing testing as part of that, or requiring some testing?
We certainly can. We absolutely can. So there's an option for testing, and you don't have to do testing. So if you want to do testing, I would say go for it. If you don't, we can do it as well. Yeah. And then the other piece, so just go to the website, you'll see those, and we'll have links on Anna's page. But go ahead. I know you had a couple other questions.
No, it's good. No, I love that stuff. But, I think testing, it just reminded me of the Dutch testing, and you've done a great job on that, and how that's great for doing that testing at home.
Yep.
And just looking at those markers, I think it really does. I mean, so motivational to kind of look at those markers, like, and just staying on top of that. Even if we're at our peak of our health, what are our numbers at peak health, right? Versus where are we right now, and how can we just move one step better? I think methylation has a big role in diabetes and those aspects too, which is important in the methylation diet. That I know it's keto alkaline, so I'm sure
it is. Yes, it is. That's right. It certainly can be. I mean, you can turn the volume up on the keto piece as need be. The alkalinity is obviously really there with our recommendations, but there's some leeway. Clinicians prescribe this, and like I said, they can layer it into other stuff. So my interpretation of the methylation diet is definitely more keto alkaline. Yeah, I know. Your strips are great.
Yeah,
they are useful. Yeah.
Man, it's a habit. Those things, if it falls by the wayside, if I stop testing, I'm like, I get so loose, and I'm like, have to go back to testing, and just making sure that I'm hitting those alkalinizers, and just recognizing how important plant food is. Like you said, the amount of epigenetic adaptogens, is that how you say it? Epigenetic adaptogens?
Yeah, or methylation adaptogens, either way. Yeah, definitely.
All right. What do you want our audience to know going home with?
So methylation is way more than MTHFR, way more than MTHFR, way more than B12 and folate, way, 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 way more. Every cell in the body, all of the time. And there's so much more that we can do to balance it. So, so, so much more. Just embracing a healthy lifestyle, one step at a time. And you're on your way to taking care of this very fundamental process in the body.
Love it. Thank you. Thank you, Kara. Appreciate you and appreciate our listeners out there today. Thank you so much. Please comment below. Definitely share this methylation. There's a lot of confusion around it. And just getting this big overall picture is huge. And visit Dr. Kara at drkarafitzgerald.com. And also remember that our podcast is on iTunes, so please listen and give us a review, and we look forward to more opportunities to interact. So thank you again, Kara, for being with us, and thanks to all our listeners.
Thank you. Great to be here.